Okay, example 9. We're going to use inverse functions to solve. So first, let's just find our solutions. Let's find all of them. We're not restricted, so remember that's going to be our plus 2 pi n or plus pi n, depending on what quadrants we end up with. And so the first thing I need to do is be able to factor this, because I have cosine squared and cosine, so I need to have it set equal to 0. So I'm going to end up moving that 5 over by adding it, so we get 6 cosine squared of x minus 11 cosine of x plus 5 equals 0. And then this is just our alien, so man goes vacation, kisses his wife goodbye, he's gone, but because they're aliens, when they kiss, she multiplies by him. And then if I can factor that, I would have to have gone back to my original equation and use the quadratic formula, but we can factor this one. So it's got to multiply to be cosine squared, so we know it's cosine and cosine. It's also got to multiply to 30 and then read it backwards, add to 11, which is 6 and 5, so bigger number first. Bring down that first sign, and then a negative 6 times what gives me that positive 30? Well, that would be a negative 5. Then remember, bring the man back. She's mad. They divide by him. Reduce it if possible. And then if it doesn't reduce down to a whole number, throw the number on bottom in front of the x. And because we're done with our factoring, we go ahead and set it back equal to 0. And then because they're being multiplied, we know that we set them each equal to 0 individually. And so then we solve for our cosine on both of them. So for the first one, you add the 1, and we get cosine of x equals 1. For the second one there, we add the 5, so 6 cosine of x equals 5. And then divide by the 6, so cosine of x is equal to 5 over 6. So, working the one on the left, remember I said if it's equal to 0, 1, or negative 1, and it's sine or cosine, that it's going to be a quadrantal angle, which means it's lying on the x or the y-axis. So, my angle here, x equals, all right, remember cosine is your x value, and so where is x equal to a positive 1? Well, x is positive 1 over here, and on my unit circle, that's at 0. Because our problem's not restricted, we put the plus 2 pi n. But we can reduce that even more. What is 0 plus 2 pi n? Well, it's just 2 pi n. All right. And so don't forget, remember, we need to put that n is an integer. I spelled that wrong. Integer. Sorry, guys. All right, so then for the second one there, we have cosine of x is equal to 5 over 6. Well, cosine is positive in quadrants 1 and quadrants 4. And so I look in quadrant 1 or 4. Cosine is x. And so I look to see where is my x value, 5 over 6. But you're not going to find it. It's not there. It's not one of the angles that are actually on my unit circle. So what do we do when we're looking for an angle and it's not on my unit circle? We're going to use the inverse trig functions. Either you can write it as arc cosine or inverse cosine. So I know it's going to be the inverse cosine of 5 over 6. But remember, be careful because we said, well, let me go ahead and put the plus 2 pi n because it's not in quadrant, 1 and 4, and they're not across from each other. But now, before I do the second one, because this would be my quadrant 1, and then I got to find that quadrant 4 angle. So think about this though. If I'm up here and I know that, like, let's say I have this angle here. This is, we'll just call it theta. So that's going counterclockwise. Well, what if I decided to go clockwise theta? That's going to give me a quadrant 4 angle, but it's because I'm going clockwise. Remember, this is going to be a negative theta. So if I said that this was, let's say, pi over 4, then this bottom angle here then would be negative pi over 4. It's the same angle size, just in the other direction, so it's going to be negative. So it's the same idea here, because my quadrant 1 is the positive inverse cosine of 5, 6 plus 2 pi n. Then my quadrant 4 angle is going to be the negative of that. So it's the negative inverse cosine of 5 over 6 plus 2 pi n. We don't actually put that in our calculator. We just leave that as it is. And this whole little piece right here is my solution.